Okay, in this video we're going to go over all things segments, so segment addition postulate proofs, part plus part equals whole problems, how to find fractional distance, using ratios and fractions in order to find the location of new points. So we're going to do it all. So the first thing you should notice in this is that we gave you a fully worked out problem that tells you the steps and things. So we have a part plus part equals whole. And then your next step would be to substitute stuff in and get 2x plus 5 equals 19 because I took the two parts, I added them together to get 19, and algebra your way into x equals 7. Below is the proof way of doing things. So here's the picture. I gave it to you. Use part plus part equals whole, which is the segment addition postulate. We do substitution, then combining like terms. And then we have the addition property of equality, which is not the addition property of equality. That is the error in your notes. It should be the subtraction, because I'm subtracting 25 from both sides. Okay, so make that fix. And then the division property of equality there. So down below here in example 3, we have the following. So it looks like we got a part plus part equals whole situation because it wants us to find ln, so that is the segment addition postulate. Okay, so I'm going to plug stuff in, so I end up with 10 plus 2x plus 17 is equal to 19 plus x. Sorry, I forgot to write out the parts, so lm. And remember, a bar on top means that we're naming it, it's the object that we're talking about. Whereas a bar without, like this guy, means we want the value. So we're looking for ln, that's our goal. So we want the whole. So if you stop at x equals something, then you're going to mess up. So the next thing we have here is substitution if I was doing the proof. Now I combine like terms. I end up with 2x plus 27 is equal to 19 plus x. That is our combine like terms. Now I need to subtract an x from both sides so that I can get x by itself. I'm left with x plus 27 is equal to 19. That is the substitution property of equality. Then I subtract 27 from both sides, and I'm left with x equals negative 8, which again is the subtraction property of equality. Okay, but I'm not done. It wants to know what is ln, so I need to substitute in again. So I know that ln is equal to 19 plus x. It is our whole in this case. So this is going to be 19 plus negative 8. That's substitution. And then when I combine and simplify, I get ln equals 11. So that is simplifying. Or combining like terms, whichever. And so now I know that ln is 11, and I am done. That is how we solve for ln. So make sure you're paying attention to whether or not you're supposed to plug it in or not. Our next one is point T is on SU, so I'm going to draw a picture. I like to draw my picture here. So I have SU, and I know point T is somewhere on here. I'm just going to draw it wherever. And it says given ST is 3x minus 1, and SU is 4x plus 1, and TU is 3x, we are trying to solve for SU. So this is another one of those where if we get x equals something at the end, we're not done. Okay? But it's also part plus part equals whole, so part plus part equals whole. We have 3x minus 1, and this is ST, over here, let's write it in blue. So we have ST plus TU equals segment SU. Then we plug stuff in. 3x minus 1 plus 3x is equal to 4x plus 1. Okay? And so this was the addition postulate. This was substitution again. So this next guy, now we combine like terms. So I'm left with 6x minus 1 is equal to 4x plus 1. That's combined like terms. I'm going to write over here because I ran out of space. So then we subtract on both sides the 4x. So I'm left with 2x minus 1 is equal to 1. That is the subtraction property of equality. Then I add 1 to both sides, so we get the addition property of equality, which is 2x is equal to 2. Then we divide by 2, and I get x equals 1, which is the division, P dot E. But I'm not done. I got to plug it back in for SU, and SU equaled 4x plus 1, which means that it becomes 4 times 1 plus 1. So SU equals 5. And that is substitution for this step and simplify. And that is how you do that problem. And I know it's crazy because it's all over the place and crazy. So example 5. So example 5 is the different kind. So here we were trying to find the whole section, but now we're looking for location, location, location. Okay? So there's some things we have to do. So we have the endpoints of F and G. So I've got to draw a picture. So I have F and G are located at -5 and 10 respectively. And it says point P is located 2/5 of the distance from G to F. That's important. I made a mistake in class over this where I said that this was 2/5, but that would be if it's from F to G. This is G to F. So from G to F, this is going to be 2/5. Okay? Another way to think about it is that this particular distance is 2x. And that this particular distance is 3/5 of the total, or 3x. Okay? And so knowing that, now all I need in order to make my part plus part equals whole is this guy right here, which is the total. And in order to find the total, we take the difference of the endpoints, or we take the highest endpoint, which is 10, and subtract it from the lowest endpoint, which is -5. And when I subtract a negative like that, I get 10 plus 5, or 15. And remember, your distances have to be positive. Key takeaway. Distance is positive. So if you went the other way and you did -5 minus 10, well, then you would need to make it a positive 15 because you would have a -15. So now we have our part plus part equals whole. We have part plus part equals whole, where we have 3x plus 2x is equal to 15. So we have 5x is equal to 15. X is equal to 3. Now, this is where a lot of you in class stopped. You said x equals 3, so you're good, but that's not what we want. We want to know where P is located. So there's two ways we could do it. We could plug it in this gap. So from F to P is 3x. And we just add to whatever value we had here. And that's probably the easiest way. The other way is we could plug it into this guy and then subtract from 10 if we wanted to. So I'm going to plug it into the first guy from F to P. So I know that FP is equal to 3x, which means that it's equal to 3 times 3, which is equal to 9. So I know that this distance right here is 9. Which means that from -5, I need to travel 9 hops. So -5, -4, -3, -2, -1, 0, 1, 2, 3, and 4. So P is located at 4. So P is equal to -5 plus 9, which is equal to 4. Okay? And that is the location of P. So let's try it again with 6 now, except 6 this time has a ratio and not fractions. So for a ratio, we do the exact same thing, except we don't have to deal with fractions. So we have F and g, and f is at -3, g is at 9. Our ratio says that we are at a ratio of x to 3x, or better yet, 1 to 3. So I have 1 to 3. Okay? Fractions are just like ratios. It says 2 out of 5, so it's 2 to 3 in order to get the 5. So it's very, very similar. Okay? So we do the same thing. Part plus part equals whole. We have x plus 3x equals, oh, I don't know my whole, so I got to find it. So the total equals the higher endpoint minus the lower endpoint. I have double negative here, so 9 minus a -3 becomes 9 plus 3, which is 12. So my whole is 12. I have 4x equals 12. I have x is equal to, I divide both sides by 4. And I get x is equal to 3 again. But now I want to know where p is. So we plug that in from fp, sorry about the bell. So fp was x, which means fp is equal to 3. So then p is equal to f, -3, plus the distance we went, which is 3. So p is located at 0. And that is that. Okay? We have 2 more examples with this video, so let's finish up. So in this example, we're talking about a midpoint, which is a type of bisector, and it wants us to find EF. So it tells us that, and they give us a picture, which is nice. It says E is the midpoint, so I'm going to use some notation for that. Since E is a midpoint, I know that each of these sides are equal. So if I have a midpoint equals each segment on either side of the midpoint is equal. Okay? So if that's the case, if DF, the whole thing, is 8, then I know that this guy is x and this guy is x because they're the same. So if I do part plus part equals whole, then I know x plus x is equal to 8. 2x is equal to 8. So I can divide both sides by 2, and x equals 4. Now it asks me for EF. Well, I know that EF is equal to x. Therefore, EF is equal to 4. Okay? For number 7, or sorry, not number 7, for number 8, that's another error. So for number 8, the midpoint of FG, so we have a midpoint, so I'm going to go ahead and label, even though there's numbers already, I'm going to go ahead and label it so I know. It's a midpoint, so I know that those two are equal, but wait, they didn't give me a total this time, so how am I going to do this? Well, both of these guys are equal, and I have both of them. I can set them equal to each other, where I say part equals part. So 10 plus 5x is equal to 10. Subtract your 10s to get x by itself. You get 5x is equal to 0. If you divide by 5, you get x equals 0. And it said solve for x. So we are done. And that is how you do segment addition and all the things.